But we're going to actually do this little chart, and I think it'll make more sense, and it'll maybe come back to you. So if you want to look here, complete the table, identify the leading coefficient, the degree, and the behavior of each polynomial. Okay, let's look. I'll color code for you. So your leading coefficient here is a 4, leading, meaning like the line leader out in front. Leading coefficient is 4. And since that leading coefficient is positive, we know that the right side of the graph needs to end up going up. Okay, the degree is what? 7. There you go. 7 is an odd number. And so you would say, okay, it's odd and it's positive. If it's odd, they go opposite directions. Since it's positive, the right side goes up, which means the left side has to go down. You could type this in on your graphing calculator if you want to see it, but we're just trying to use the patterns right now. And so then let's talk about end behavior. We're going to do these first two lines together. Let's talk about left and right, because that's what we're talking about. If you look at my number line on the wall, you can see on the left side of the number line, it says negative infinity. So if I'm talking about the left side of the graph, I'm saying as x heads towards negative infinity, the graph goes down. So f of x, the y values go towards negative infinity because it's going down on the left side. What's the right side do? Yeah, it goes up, right? So it goes to positive infinity. So if you look at my number line on the wall, I'm saying as x heads to the right, as x heads towards positive infinity, as we go to the right, f of x or the y values go up towards positive infinity. So what you see here, this is what I mean by end behavior. Where does the ending pieces of the graph go? Negative infinity, positive infinity. Okay? We'll do one more together. You'll do the last line on your own. Okay, the leading coefficient here is what? Negative 7. So obviously this time it's negative. And what's the degree? Yeah, highest exponent, 6, which by the way, if it's in factored form, you would add your exponents, but here we'll take the highest. So that's even. Evens go the same direction, so even, negative, it's going to go same direction. They both go down. And then that means that both of your end behaviors here should be towards negative infinity. So I'm going to go ahead and just copy that little first part. So left, right. As x goes to the left, f of x goes to negative infinity. As x heads to the right, and I'm not saying right, I'm saying as it goes to the positive infinity, but that's what that means. F of x goes also to negative infinity. So this is my end behavior. It's based off the ending arrows of the graph. Can you please try this row at your table and then check it when you're done? Okay, go ahead and check that. And if you have any questions, ask me now. Quadratic, right? You know that if it's positive, it looks like this, where it's up, up. What's a negative look like? Down, right? So that's what we're trying to understand is so if these are the most basic degrees, right? To the first power, to the second power, any of the other iterations where it's a third degree, fifth degree, seventh degree will follow the same pattern as a linear, where the right hand goes up, left hand, and then if it's negative, right hand goes down. If it's an even degree, 2, 4, 6, 8, it's going to follow the same pattern as a quadratic, where they both go the same direction, positive up, negative down. Does it help a little bit? Okay. You ready? Look at the end behavior. So it is on the left side going towards negative infinity, and on the right side it's going towards positive infinity. So you can see they're going opposite directions. It asks you for, is the degree even or odd? I'm not asking for the specific degree, but would it be even or odd since they're going opposite? Odd. Odd is opposite. So we know for sure it's odd because it's going opposite. And the leading coefficient. Yeah, you look at the right side of the graph. Since it's going up, then we would know it's going to be positive. Odd, positive. So we're just looking for patterns, okay? And this is why you look at the right side. Okay, can you look at the next two and try them? See if you can get it. A what? I don't know if I have one that's clean. Okay, look at the middle one I think should be kind of easy, but this one here, if you get confused about the odd, look at the right hand. Since it's going down, just like a negative line, that's a negative function. Okay, before we flip the page, I want to point out something because we're about to talk about turning points. Okay, if you look at this very first graph on number 4, it has 2 turning points. There are 2 spots where it switches direction. That's a cubic function. This next one I assume is quartic because it has 1, 2, 3 turning points where it switches direction. What about that last one? How many times does it switch direction? 1, 2, 3, 4. Okay, so it's probably has a 5th degree, I would guess, okay? The thing about turning points we're about to do on the next page is that your maximum amount of turning points is at most 1 less than the degree. So if this one is a degree of 4, it would make sense that it has 1, 2, 3 turning points. This is a degree of 3, which I believe it is, then it has 2. That makes sense. So if you want to flip to the next page, that's all we're talking about is like how many turning points can you at most have? You look at the degree and you take away 1. So if I have, look at this first one, my degree is 6, then my maximum amount of turning points would be 5. And that's 5 at most. So it could have less than that because if you have like more multiplicity on a certain 0, then it might be less than that. Okay, this one should make sense because you have a degree of 2. So then you know what kind of function that is. What is that? Quadratic. So it looks like this, which has how many turning points? 1, which is going to be, that makes sense, right? You had 2, at most 1 less. Again, at most. Which it would have to have 1. So quadratic. Okay, and then this one is quartic, and it's even positive. So quartics usually look something like this, where it's kind of like a W shape. And they typically have 3. At most. You could have less. Does that sort of make sense? Okay, we're going to do the one graph on the next page. We're not doing all of them. There's some steps here about how to graph. We're actually going to skip 2 of them. So I believe it's steps 3 and 4. Yeah, it says find the zeros and the y-intercept, plot them. And then it says make a table to find more points. No, I will not. So I'm going to skip steps 3 and 4 because it's unnecessary, but I left the table on there because I forgot to delete it. You're going to use your end behavior in your graphing calculator to help you. So if you could please type this into your graphing calculator now. Okay, go ahead and type it in to your calculator, please. If you try and factor this guy, my GCF the left side to be x squared, 2x plus 5. GCF the right side is -1. It's going to be x plus 6. Do those parentheses match? No. So what that tells you is that this doesn't work. You can't factor by grouping right now, which means that you're going to have to use your graph instead. So if you go to your graphing calculator and do what we've done earlier this unit already, which is to find one of the x-intercepts, that's really nice. So find one that's an integer. On a TI, sometimes the fastest way, instead of doing like the trace or calculate, you can also just go to the table and look and see, okay, where's my y value 0? So you would click second graph if you want to see the table. If you're on a Casio, it's really quick. Remember to do shift, and then you click F5 because that's G solve, and then you should be able to solve for all of the roots. Okay, did you find a good one? I think there's a couple actually, but the easiest one to see is 1. Do you see that? Positive 1? Okay. And then there's also -2, which is a good one, but I'm going to go ahead and use +1 just because it's a little bit easier to see negative 2 butts up right next to the other one, which is negative 1.5. So I'm going to use 1, and this is one of your x-intercepts that we are grabbing from the graph, okay? So if you want to make a note to yourself that this is an x-intercept from the graph, okay? And then we'll do synthetic division with that, because then you can use that to factor the rest. So if factoring straight out the gate doesn't work, then grab one of your zeros first. Okay, so to go ahead and do the synthetic division, make sure your remainder is 0. Yeah, your remainder ends up being 0. And so now we're going to go ahead and factor what's remaining, which would be 2x squared plus 7x plus 6. Some of us made some little mistakes yesterday on our factoring. I'll pass it back Monday. When my a value is not 1, I have to make sure I multiply a times c. So that'd be 2 times 6, which is 12, and adds to 7. Then you play the x game. So can you go ahead and factor that? You can factor it by grouping, unless you have a different method you like to use. So we know these two zeros, and remember, then you also have to take this guy, which is the one that's you already saw. If I want the full factored form, all the factors, then you also have to list this one, which if I have positive 1, I have the factor x minus 1, which you may have forgotten yesterday in your progress check. Okay, so then the 3 zeros that I see, obviously the one that I already had, x equals 1. And then the other two that you probably see on the graph are negative 1.5 or negative 3 halves, because you would subtract 3 and divide by 2, and negative 2. So we're going to not use this table. Sorry, should have deleted it out. We are going to just list out what are the points that we have. So we have my zeros, or my x-intercepts, are 1. Negative 1.5 or negative 3 halves, and negative 2. But I don't want your decimals, so please don't give it to me as a decimal. And then the other thing that I need you to give me is the y-intercept, which you can solve on your graph either by looking at the table, by tracing it on the graph, or you can plug in and solve, which is super fast because, let's see, if I want to know the y-intercept, I would go 2 times 0 to the third plus 5 times 0 squared, plugging in 0 for x, minus 0, minus 6. And these all go to 0, 0, 0. So what's my y-intercept? Negative 6. So I just did that at the top. But you can trace it on your graph. So if you have a Casio, you would click that one that says G solve, and then you can solve for the y-intercept. It actually says y-intercept for you. On a TI, it's probably quickest to just go to where x equals 0 on your table and just read it. Okay. There you go. So you have all the points that you need, and so we're just going to go ahead and graph this. You have 4 points to use. Now, you can see what it looks like, right? So you can see pretty clearly that in between negative 2 and negative 1.5, it doesn't go up very high. So you need to make sure that yours mimics the same way. So negative 2, negative 1.5, really close to each other. My other 0, or x-intercept, is at 1. And then my y-intercept is at, not on the x-axis, the y-axis down here. So that's the other one that I expect to see. And when you go to connect it, again, I don't want to see, whoa, no, it doesn't do that. You can see it barely goes above and then turns and comes right back. So then this one dips further down because of the y-intercept and then goes back up. It should look like what you have, and you can see, oh, look at that. We did the end behavior, but I probably should have had you pull it from the graph. The end behavior, do you see it on your screen? Because this one is odd and positive, it goes like that. So if you want to explain that to yourself a little bit, you can. But again, you're going to be able to see it, so you don't have to memorize it necessarily, okay? You can check these things. So there's your end behavior at the ends of the graph. Ta-da! Okay.